So now we're going to start our next section, which is 13.2, and it's about limits and continuity. So I just want to real quick remind us of what happened with limits when we were talking about functions of a single variable. So if we have f of x and we want to talk about the limit as x goes to c of f of x, if you remember, we had one-sided limits. So let's say my function does something like this. Here's c, and you would approach from the left and approach from the right. And if those limits existed and they were the same, then if they were existed and they were the same, then we would say that the limit exists, and the limit as x goes to c would be equal to a. So basically we approach the limit from both directions. We could only approach from the left and approach from the right. We approach c. So now let's think about our function of two variables here, f of x, y. And remember, my domain now is in the xy plane. And so here I have a point, and there are many different directions you can approach from here. So I'll say there are many directions, many different directions you can approach from. Because we're in two-dimensional space, there's a lot of ways you can approach. I can approach from here. I can approach this way. You don't even have to approach in a straight line. You could approach that way. So it gets a lot more complicated when we're talking about functions of two variables, but we do have a lot of our same limit rules from before. So when you previously, if you take the limit as x goes to c of x, it's c. You have the same thing here. The limit as x goes to c, or sorry, we're two variables now. So the limit as xy approaches ab of x would also be a. And the same thing for y. The limit as xy approaches ab of y would be b. And then for polynomials, remember, so if p of x is a polynomial functions are continuous everywhere. And so if I take the limit as x goes to c of p of x, it's p of c. So in our function of two variables, if I have a polynomial function and I take the limit as xy goes to ab, again we can just evaluate. So this would be p of ab. So on the left I have the statements for functions of a single variable, but we get corresponding results for functions of two variables. That's the column on the right. So now let's find some limits here. Let's look at this example. Find the limit, and it's going to be the limit as xy goes to 1, 2 of 5x squared y over x squared plus y squared. So we're going to look at the limit. This is a rational function. So we're going to look at the limit at the top of 5x squared y. Well, this is just a polynomial, so we just evaluate. This will be 5 times 1 squared times 2, or 10. And then we look at the limit of the bottom. The limit of the bottom. And it'll be x squared plus y squared. And then you just evaluate. Again, this is a polynomial, so 1 squared plus 2 squared is 5. And what's important is that the denominator limit was not 0. So then, because we didn't get 0 for the denominator in this rational function, we can now split up the limit into the limit of the top and the limit of the bottom, which was 10 over 5, or 2. And there is my limit. So if you have a rational function where I have a polynomial on the top and a polynomial on the bottom, check to see what the limit is of the denominator. If it's not 0, you can just evaluate your rational function at your point.